Good day, everyone. So we are back for today's video. This is the last topic of the atomic physics entitled Atomic Transitions and Lasers. So first, let us define what is atomic transitions. So atomic electron transition is a change of an electron from one energy level to another within an atom or artificial atom. It appears discontinuous as the electron jumps from one energy level to another, so typically in a few nanoseconds or less. It is also known as an electronic or excitation or atomic transitions or quantum jump. Furthermore, electron transitions cause the emission or absorption of electromagnetic radiation in the form of quantized units called photons. So first, absorption, spontaneous emission, and stimulated emission are three related energy conversion processes. So this time I will discuss first the stimulated absorption. So when an atom is irradiated by light of all different wavelengths, it will only absorb wavelengths equal to the difference in energy of two of its energy levels. So this phenomenon called stimulated absorption that places an atom's electrons into excited states. Furthermore, stimulated absorption occurs when a photon strikes an atom with just exactly the proper energy to induce an electronic transition between two energy states. So to explain it further, so this picture, this diagram rather, um, represents the process of stimulated absorption of a photon by an atom. So energy, as you can see here, energy is on the vertical axis. Here, in the vertical axis. And nothing is plotted on the horizontal axis. So only two energy levels are shown. So this diagram illustrates only a small fraction of possible energy levels of a material. So the lower energy level is labeled E1. So it may represent, for example, the highest occupied energy level of an electron is in an isolated atom, or it may represent the valence band of a semiconductor. So the higher energy level is labeled as E2, and it may represent the lowest unoccupied energy level of an electron in an isolated atom or the conduction band of a semiconductor. So the dot here is represents an electron occupying the energy level at the start of the process. So this squiggly arrows, this represent a photon absorbed or emitted by the process. So the vertical arrow shows how the internal energy of the electron changes in the process. So during absorption, so as you can see, an electron takes energy from an incoming photon, and the internal energy of the electron increases. So thus the electron is transferred from the ground state to the excited state when the atom absorbs a photon of energy with the formula of HF equals E2 minus E1. So moreover, there are atoms in an excited state have a probability of returning to a lower level of excitation by spontaneous emission. So spontaneous emission is the process in which a quantum mechanical system such as molecule, an atom, or a subatomic particle transits from an excited energy state to a lower energy state. So it also emits a quantized amount of energy in the form of a photon. So spontaneous emission is ultimately responsible for the most of the light we see all around us. It is ubiquitous that there are many names given to what is essentially the same process. So if atoms or molecules are excited by some means other than heating, the spontaneous emission is called luminescence. For example, fireflies are luminescent, and there are different forms of luminescence depending on how excited atoms are produced. We have electroluminescence, we have also a chemiluminescence, etc. etc. If the excitation is affected by the absorption of radiation, the spontaneous emission is called fluorescence. On the other hand, so this is a diagram representing the spontaneous emission of a photon by an atom that is initially in the excited state. So during spontaneous emission, the internal energy of an electron decreases, so the photon is emitted. So in conclusion, when an atom falls from excited state to the ground state, it emits a photon energy. So before, wala pa yung photon energy. After, there is photon energy that that emits. Third is the stimulated emission. So the wavelengths that can be emitted are the same as the wavelengths that can be absorbed. If an atom is in an excited state and a photon with energy such as HF is equals to E2 minus E1 is incident on it, the probability of emission of a second photon of this energy is greatly enhanced, so the emitted photon is exactly in the phase with the incident photon. So this process is called stimulated emission. In addition to that, is the process in which an excited electron or molecule interacts with a photon, decays to an available and lower energy level, and in process gives a photon. As with the other processes, this process can occur in an isolated atoms, ionic compounds, organic molecules, and other types of materials, and it can occur in solids, liquids, and gases. Next, so this is the diagram of the stimulated emission representing uh, stimulated emission of a photon by an incoming photon of energy. So initially, the atom is in the excited state. So if incoming photon with energy equal to the difference between allowed energy levels interacts with an electron in excited state, stimulated emission can occur. So the energy of the excited electron will be converted to the energy of the photon. So the stimulated photon will have the same frequency, direction, phase, and electromagnetic polarization as the incoming photon which initiated the process. So it also occurs when a photon with energy equal to the energy gap of the lens interacts with the electron. So in that process, the electron decays to lower energy level and a photon is produced with the same frequency, direction, phase, and electromagnetic polarization as the original photon. So here, the incoming photon stimulates the atom to emit a second photon of energy. Next is lasers. Lasers are monochromatic, coherent light sources that work on the principle of stimulated emission of radiation from a system of atoms. So laser is a device that emits light through process of optical amplification based on the stimulated emission of electromagnetic radiation. So the term laser originated as an acronym. So meron siyang kanya-kanyang acronym ang laser. So the term laser originated as an acronym for light amplification by stimulated emission of radiations. So the first laser was built in 1960 by Theodore H. Maiman at Hunges Research Laboratories based on theoretical work by Charles Hartons and Arthur Leonard Scalo. Next, so this is the production of laser, everyone. So here, let us understand the laser design with the help of this schematic diagram. With the help of this schematic diagram now. So the laser consists of a tube that is filled with atoms that are active medium, an external source of energy that bumps the atoms. So it bumps the atoms to excited states. Then two reflecting mirrors are placed at the ends of the tube to confine the photons to the tube. So one of the mirror is made totally to reflecting, and the other is made slightly transparent to allow a part that the laser beam to escape. So shown here is the steps involved in the production of a laser. So first is electron is pumped to a higher energy level by supplying energy. So second, the electron in the metastable state jumps to a lower level, releasing a photon. In the third, the photon interacts with another electron in the metastable state. So this interaction produces another photon of the same wavelength and same phase. So these photons are also reflected by the mirror and the laser beam comes out. So here, through the partially transparent mirror. So these photons are reflected by the mirror, and here nga, the laser beams comes out through the partially transparent mirror. So this picture denotes also the first Rabi laser, showing the flash lamp surrounding the Rabi rod. And that concludes the topic of atomic physics. So thank you everyone for lending your ears and eyes to our presentations, and God bless you. Thank you.